So guys, really, just to make sure you're okay with this, the quiz correction and the two assignments that I handed out, practice 22 and page 154, you know again, be what day? Wednesday, I want that stuff, all right? Yep, except for on practice 22, you crossed off number 16, right, Izzy? Get that bottom one crossed off on 22. Number 16 on practice 22, very bottom one there. That should be it right there, okay? All right, guys, we've spent a lot of time looking at data in matrices about how they represent data numerically. And what we want to do today is start looking at how do we take this data that's in the matrix and apply it to some visuals. And the visuals we're going to look at today are going to be in the form of your title up there, histograms, stem and leaf plots. You're also going to hear a frequency table mentioned in this as well. Got a short PowerPoint I want to run through, but I think you'll be in good shape with this today. So to get started here, real quickly, in our focus right here, whoa, that's not good. Didn't want to black it out. In your focus right there, our focus is to use histograms, frequency tables, and stem and leaf plots to display data. All right. I think you've probably seen these before, but what we really want to get technical with today is, okay, yeah, I can form a stem and leaf plot. Yeah, I can make a frequency table. Yeah, we can produce a histogram. But the idea today is to look at that and take information to identifying trends in the data. So we'll talk about what that means here in a second. Something big going on tomorrow. Anybody tired of all the commercials?
Oh, thank the Lord.
Thank goodness the election is tomorrow, because the bashing can end on local channels, right? Okay, because Joni Ernst bashes who? Bruce Braley. And who's Bruce Braley? Bash. Bash is on Joni Ernst. Right? Okay? Well, when I was a kid growing up, my grandparents never said you should tell who you're voting for, but I'll be a straight Democrat. I'll take it tomorrow when I vote. Okay? All right. Let's go. Let's get rolling on this, guys. Let's just get through the terms here. I've got a PowerPoint that I think will tie all this together nicely today, but let's get through our terms here quickly. In our terms, first of all, we need to know what the heck a histogram is. Okay, how many of you guys have seen some of these graphs or numbers or tables that are showing the election right now? Showing who's ahead, polls and stuff. You guys have all seen that in the news before, right?
Who is ahead?
Right now, Joni Ernst is going to win. So,
Oh, what?
yeah, Taggart Branstad's going to win. The Republicans are going to take over. So, anyhow, you guys have seen that stuff on TV though before, right? The graphs and stuff on news. Yes. Hopefully you say yes and stuff like that. But politics is a lot where they're used at. But right here, first term to talk about here, gang. Is a histogram. Somebody want to volunteer to read what a histogram is for me right here? Volunteer to read that? Izzy, you on it?
Type of bar graph that shows how many data items occur in each of one or more non-overlapping views.
Okay, it's a bar graph. We all know what a bar graph is, right? Everybody knows what a bar graph is. I would hope. All right. If you don't know what a bar graph is, probably shouldn't be in here, right? Right? Okay. What I would really like you to write down here is basically it's a bar graph that shows data, and the big word here is this. What's the word I underlined there? What's the word I underlined there? It's in front of you guys. What's the word I underlined here? Somebody tell me. Intervals. And what that means is this. Bar graph that shows data in intervals. Okay, so a bar graph that shows data in intervals. And over here they're talking about the prices of scientific calculators and a cost right here. And the first interval is $30 for how much here in your notes? Take a look. What's it say in your paper? What's it say down here? What's the interval for price in that first bar? 32. 39.99. So basically anything in the $30 range. This is the next interval, anything in the $40 range. Third one's anything in the $50 range, and the last one's anything in the $60 range. Okay? These are intervals because it doesn't just include one value. It doesn't say just $31 in your total. It counts for all values in the 30s. So that interval is down here. And then over here, what's this word listed on the left right here? What's the word they listed on the left right here? Frequency is just how many times it shows up there. So which interval has the largest frequency? Which interval has your largest frequency? The 30s, right? Okay. And it makes sense. Don't people want to buy stuff that's not going to cost as much? It's true, right? Okay. All right, then frequency we just got done talking about right here. Frequency is simply going to be the number of times that data shows up within an interval. Okay. So it says right here in the histogram above, the frequency of the scientific calculator in the 40 to 49.99 range is how many? What's it say right there? The frequency in the $40 range is how much? It's 3. There's 3 of them there. Okay, you look in the $40 range. There's 3 of them here. Okay. All right. And then finally, a frequency table of all this information right here. It's just a table that tells you, it counts it out, how many are there. So according to this frequency table, how many calculators were in the $30 range? What's it say right there? Is anybody listening right now? Because if not, I'm going to stop. Anybody? I've got 3/4 of people on phones, computers, all that good stuff. Love one-to-one at Union High School. Okay? I think we're all identified. 7 of them, right? How many are in the $40 range? How many are in the $50 range? How many are in the $60 range? Frequency table just tells you how many are in each interval. All right? So, well, last thing we'll look at then here is this idea of stem and leaf plot. Stem and leaf plot, very simple. Stem and leaf plot, basically, what you need to understand is this, okay? How many of you seen a graph that looks like this with numbers in it? You should have seen it before, okay? Numbers on the left are going to represent stems. Numbers on the right are going to represent your leaves. The idea being this. Anytime you see like this 4 with a bar and then a 1, that simply means it's representing 41. So take a look at the 40s right here. Okay? What are the values of calculators in the $40 range? What are those values? There's 2 that are $40, and then the third one is what?
47.
47. Listen to this question. What's the frequency of the number of calculators in that $40 range? 3 of them. 3 different prices there, right? Okay? Now, some people like to do this with their stem and leaf plot. Basically what they did is they took all the prices of the calculators and put them in there. Obviously, which range, or which interval, if you will, has the highest frequency again? Is it in the 30s, the 40s, the 50s, or the 60s? Where? It's in the 30s, right? There's more numbers up here, right? Okay? If you would do this real quickly, just kind of, whoops, I didn't want to do that. I didn't want to cross anything out. If you would just put bars around this like so, around your numbers like so, this is kind of like a sideways histogram right there, okay? Stem and leaf plots, if you just turn them 90 degrees and put bars around them like that, can form a histogram, okay? All right. Do we understand what a histogram is? I know you've seen it before. Yes or no? Yes. Shows data as a bar graph in intervals, okay? Frequency table. If I tell you how many are in each interval, or count how many are in each interval, can you handle that? Okay, if I say form a stem and leaf plot of the data, could you handle that? Let's look at forming a couple of these right here, okay? Questions to this point? I think if we get through sample 1, we'll be good to go. I'm going to try and put, sample 1 I'm not too worried about. They give you all the answer right in here, but I'm just going to kind of put some stuff over here. It says 30 people were asked to tell how many books they had read in the past year. Here are the results of the survey. What's the first thing it asks you to make, guys? Make a frequency table, okay? I'll just kind of put one up over here on the side. It says use what intervals here, gang? What's the first interval it tells you to use right there? 0 to 9. So how many are in the 0 to 9 range? How many are in the 10 to 19? 20 to 29, 30 to 39. And what I'm putting up here in the red pen, you might just want to put off to the side. Do I have a volunteer that would go ahead and count the number of values that fall between or range to 0 from 9? Who would count that? Izzy, you want that one? Who wants the teams? 10 to 19. So all these numbers the numbers that are highlighted right here, Izzy, what I want to know is this. I want to know this set right here of numbers. Yep, how many are from 0 to 9? So I want you to tell me what's there. So it says 30 people were asked to tell how many books they had read in the past year. Here are the results of the survey. So it's a survey result. Who's got the 10s for me? Who's I do? Larry, who wants the 20s? Who'll count the 20s for me? Jaden, you want the 20s? Thank you. 30s. Who's doing 30s for me? Lily. And 40s. Who wants 40s? Jacob? Okay, 0 to 9. We had the first one for the frequency table here. 0 to 9. 6 of them. How many 10 to 19s there? We had 10 to 19. 16 of them? Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I agree. Who had the 20s for me? And? 4 of them? Who had the 30s? 2 of them? How about the 40s? How many people read 40 to 49 books in a year? 2 of them. Now, guys, right here, just a quick self-check. How many people did they say they surveyed right here? 30 people. So my frequency values had better add up to what value for a total? What had all these numbers that we just counted better add up to? 30, all right, so check it out. 6 and 16, where am I? 22 and 4. And 2 more. 28 and, where am I finally at? Okay, so frequency table. Just count how many fall in an interval. It's pretty easy to do, right? Pretty easy to do. Okay. Good. Frequency table's made. Now, could you construct a histogram out of this? Well, I'll just make a sketch of it right down here. Obviously, which interval is going to have the tallest bar? 10 to 19. There's way more of them here. So if I was making a sketch of this, my intervals might look like this. Oh, better make that smaller. I'm going to go 0 to 9 in the first interval, 10 to 19 in the second interval, 20 to 29 in my third, 30 to 39 in the fourth, and my 40 to 49 in the next one. Okay, how many were 0 to 9 again? How many were there? No, there were 6 of them. Let's just say 6 falls right about there. Now, is the second bar going to be taller than that or not taller than that? A lot taller or a little bit taller? Yeah, a lot taller, right? Might look like that. How about the 20 to 29? How many were there? 4. So will this bar be taller than any of the others or not? It'll be the shortest, right? Pretty simple, isn't it? And then these last ones, both at 2. Guys, does the graph that I've put up here, does it look somewhat like it might fit this data in the frequency table? Does this visual match the information in this frequency table? It does, doesn't it? Okay. All right, so I think you get what this stuff means here, okay? Quickly, notes-wise, I'm not going to get too picky about what you do here with this, but I just want to make sure you understand, first of all, what they are and you're able to answer questions off of them. And it sounds like, to me, you've got a pretty good handle on this. So, quickly here, I just want to run through this. You guys got this PowerPoint on paper, but stem and leaf plots right here. We all understand that, oops. You guys all understand that right here, this part that I'm looking at right down here, this 9/7, what's that mean right here, guys? 97. So if I said what value was in the 50s for this example right here, what would you tell me? What value is in the 50s? The value is 52, right? Okay. Notice how they put these values in order then. So you want to make sure in stem and leaf plots you put stuff in order. But does everybody understand this key right down here? 9 bar 7 represents 97. So this 5 bar 2 represents 52. So guys, real quickly, let me ask this question. How many 76s are there in this data set? How many 76s are there, though, in this data set? 1, 2, 3 of them, right? 76 is accounted for how many times? I got 76, 76, 76 again here, don't I?
Yep.
Don't those three values account for that right there? Okay, so you understand that. Let's see. It says in an ordered stem and leaf plot, the data are in order from what? Least to greatest. That makes sense. Okay, I think we're okay with that. Stem and leaf plots. They're easy to create. They don't become unmanageable when the volume of data is large and no data is lost. You know, this really just kind of tells you why we would want to use them. So not a big deal there. I think there's too much here. How to construct a stem and leaf plot. Obviously, you always want to look for the highest and the lowest values of a data set. Decide on the stems. I always say go by tens. That usually works pretty well. You can list your stems in a column from least to greatest, and then use each piece of data to create your leaves. That's pretty much what we've done already. Oops. You guys ever heard of a back-to-back stem and leaf plot? Anybody ever heard of that? Okay, back-to-back stem and leaf plots are like this. You might have a stem and leaf plot. You guys have this class third hour, right? And have you talked to any of the other kids in sixth hour before that have the same class? So if you have or have not, there'd be like two classes. So if I wanted to put like test scores in a data set for, say in this example, second period, I could list everything off to the left, then anything over here on the right would represent fifth period class. So all you're really doing is kind of taking a stem and leaf plot and leafing out both sides, right? One's just going to represent second period here. One's going to represent fifth period. So you can kind of compare the scores right here with different classes in that example. So you might see something like that. But honestly, let's keep that table. Not worried about that. We'll do this. And that. Frequency table. Sometimes in frequency tables, instead of just counting them up right here, some people like to put a tally mark in there. If you want to do that, that's fine. But in the end, at least put them as numbers for me. Okay. All right. Guys, what questions have you got on this? It's all stuff we talked about in the notes. Any questions at all? Notice right here, guys, it says histograms and bar graphs. Again, down here they always show data in intervals. Are there any gaps between the bars here when you do these? Are there any gaps between the bars when you do these? The only time you would have a gap is if one of the frequencies was what value down here on the end? 0. The only time you won't have a bar in an interval is if the frequency within that interval is 0. That would be the only time you have a gap. Okay. All right. Questions for me at all?